Hey guys, this last week we're going to be talking about polar coordinates, and this is a completely different way of thinking from what we've been doing, but there's a definite connection. So let's go ahead and talk about that. So when you have a regular coordinate plane, and we have this point, and that point represented x and y. So in trig, we looked at this as a right triangle with this is x and this is y, and this is our hypotenuse, which was also like our radius. This is also theta. So knowing that, we are good with that. So now what we're going to do is we're going to come over and apply this to a polar coordinate. So instead of having an xy coordinate, our polar coordinate is going to be our theta. It's the same r and the same theta as over here, but this is how we're going to write it. So your r is your radius. So notice these like concentric circles here. I'm going to erase this in a second. We're going to go out by those circles. So our radius, we're going to go out so far. So let's say our radius is like 3. So we're going to go out 1, 2, 3. And then let's do concentric circles here. So this circle right here, this last one, has a radius of 3. And so let's pretend like our angle is 45 degrees. So let's see if it looks like this one right here is our 45-degree angle. So then that point would be where those two meet. So that point right there is going to be our polar coordinate. So I have a bigger graph here, so it's going to be a little bit easier to find this concentric circle. So we're going to try another one. Let's try 2, -60. So I'm going to go out, like there is a circle with radius 1. So here's a circle with radius 2. So we're going to go out to here, and it's -60 degrees. So guys, remember, positive angles always have gone counterclockwise. Negative angles have always gone clockwise. So we are going -60 degrees. So let's see. So right there is going to be our point. Okay, so now that we found this point, I'm just going to call this point A. Let's go ahead and like do some different things with it. So remember, think about like coterminal angles. So there's a lot of different ways that we can get to this point. Oh goodness. Besides just having the two -60 degrees. So let's kind of think about something else here. So if we just went like +2 this way. So what if we went -2? So we're over here. So like this is our 0 and we're going this direction. So let's think, oh, sorry, right here. So this direction here. So that is going to be a positive angle. So let's see. We have a positive, we're going from 180 to 300. So think about what that would be. 180 to 300. That's going to be positive 120. So another way to say this is -2 right here because we went out 2 and we swung around positive 120 degrees. So this would be another way of writing that. Okay, so let's think of yet another way to plot this point A. So let's go back to like a +2. So we're right here and we're going all the way around the circle. So think about like your bearing. So that would be +2, 300 degrees. I guess bearings would be up here, but the rotation there. +2, 300 degrees. So you are also going to see this not in degrees, but in radians. So I wanted to come up with another example that has radian measure. So go ahead and see if you can plot this point. So remember, I would start here, and then I would swing out to the angle. Okay, so I went out -5 and then I swung around 90 degrees to down here. So That's where our new point is going to be. And so we're going to do some, let's see, I erased it. 1, 2, 3, 4, 5. We're going to do some different things with it. So I want you to think about like another name that you can name it. So what if I did like +5? So if I went out +5, 1, 2, 3, 4, 5, I could swing out in this direction, and get like -pi/2. I could also go this direction and get +3 pi/2. So like you just have some different options there. So that is how you graph polar coordinates. Okay, so for this next part, it's really important to be able to flip-flop back between the two types of coordinates. So like this would be a type of coordinate point for polar, and then like let's say if we have like 1, 3, that would be a type of coordinate point for the other. So like for instance, on this one, I might say that the rectangular coordinate is 0, -5. Like that's pretty easy. But like for this one up here, that wasn't that easy. So we're going to have to learn algebraically how to do this. And so this is when when you have like the polar coordinate and you're going to just like the coordinates that we're used to. And this is going from like a regular like XY coordinate to a polar coordinate. And these formulas are really nothing new. So think about like the formula for cosine. So cosine is x/r. So notice all we're doing is just solving for x here. And same thing with sine is y/r. And so all we're doing is just multiplying those together. This is just that basic Pythagorean theorem, like x² + y² = r². And then this is the tangent formula. So we're just using those formulas that we've really talked about before to our benefit here. So what we're going to do is I'm going to give you three examples, and we're going to go through each one of these. So we have these 3 examples. So the directions say plot each point by hand in the polar coordinate system. So this is what we've done. So this is nothing new. So this is 1, 2, 3 right here. So oh, sorry, it's 2, isn't it? We went out 2, and then we're going to swing up 30 degrees. So it's right there. So let me erase what's going on here. These are kind of small. So we're going to go out 1, 2, and then go up right here. So this is going to be where our P is. Okay, so this is great that we know, from a polar coordinate, like where that is. But think about this. I mean, this is also going to be on a regular XY plane, and we need to know where that point is from that perspective as well. When you're going from polar to regular, we're going to use these formulas here. So go ahead and plug in those formulas and see what you get. Okay, so I showed my work here. And again, this shouldn't be anything too new. This is just algebra. Okay, so I'm going to go up here. It also asks us to find 2 other coordinate points. And so this is what we did up here, like with this stuff. So go ahead and see what you can do as far as 2 other coordinate points. Okay, so for my 2, I chose to do -2, -150. So let's think about that. So we went out 2, and we're going -150 degrees that way. Remember, this is going to kind of hurt your head a little bit. But just like go back to what you know. Oops. That when you go, I must have erased it. When you go in this direction, that is a positive angle. When you go in this direction, that's a negative angle. So I was going in this direction, so that is a negative angle. Okay, and then also +2, so I went out this way, and then I went all the way around. Again, that was also negative because that's that clockwise position. So I went all the way around to 330. Okay, I want you to try your hand with these 2. Note that they are both radians. So just think about like, what that would be as far as location. Think about it in degrees and see what you can do with that. Okay, so I took each of these and I graphed them, and I don't know, sometimes I like to put like the coordinate plane to kind of help me get my bearings. So I went out, like for this one, I went out -4 and then I swung around 120 degrees. And then I just followed the formula to get the coordinate points. Oops, that looks terrible. But just know that like I'm always going back and saying, okay, well, does this make sense? So like if I had like, let's say I had like a -2 here, well, then I know I've made a mistake somewhere. I've either made a mistake in my algebra or in my graphing. And then the last thing I did for both of these was I found some more coordinate points. So here I just found 3. We just needed to find 2. Over here I found 2. So go ahead and look those over. And if you have any questions, reach out, let me know. For this last part, we are going to try to figure out like how we get from a regular coordinate point, what we're used to a polar coordinate point. And so I have this right here. And so hopefully you're kind of getting an idea of maybe what that polar coordinate point would look like. And then I want you to know that, okay, so we are going from regular to polar. So we're going to use this one. So we're using this formula to find r and the tangent of theta to find theta. Okay, so I did the math on this. R was pretty straightforward. We got the square root of 2. And then, so theta, make sure, okay, so you set it up and you have the tangent theta is equal to -1. We have to do the tangent inverse to find theta. So I looked back up here and we're in quadrant 2. So then I know that theta in quadrant 2 is 135. So my polar coordinate point, obviously know that there's others because we've found several before. This one would be square root of 2, 135. So let's think about this. I'm going to go out square root of 2 and rotate around 135 degrees. So like that point right there. Okay, so let's go back up to our directions. So we plotted the point here, and we give 2 pairs of polar coordinates between 0 and 360. Okay, so this is 1. So because it has to be between 0 and 360, let's go to like maybe, let me change colors here. Negative square root of 2 and see what happens there. So if we have a negative square root of 2, right here, we'd have to go all the way around the circle to make it positive. So let's see, that would be, let's do the math here, 315. So here are 2 possible coordinate points. So I want you to do these 2 and see what you get. Okay, I'm running out of time, so this might cut me off, but this one I didn't do any formula because we can kind of see from where it's located that the radius we went down to and the angle is 270 degrees. Also on the last one, I just did the formula and I got r equals 1 and my theta, my reference angle is 210, so my theta was 210. And so these are my other angles. So that's it, guys.